If you've ever been curious about what each computer component does but never had the time to figure it out, this video is made just for you. Just 5 minutes and you know how computers work. A computer is made up of 8 main components: the case, power supply, motherboard, processor, cooler, RAM, storage, and graphics card. Case. This is the metal box that holds all your PC components in an organized way. Cases come in different sizes: full tower, large cases, over 50 centimeters; mid tower, the most common type, 40-50 centimeters; mini and micro towers, compact options, around 30 to 37 centimeters; SFF, small form factor, the smallest cases, including styles like desktop, cube, and sandwich. Power supply. This unit powers your entire PC. It converts AC electricity from the wall into DC for your components. PSU power is measured in watts. Most of the load goes through the 12V rail. Many power supplies are 80+ certified, meaning they operate at 80% efficiency or more under full load. Power supplies come in different sizes: ATX, which is used in most cases and measures 86 millimeters in height and 150 millimeters in width, and SFF, TFX, and Flex ATX, which are designed for compact cases. Motherboard. The motherboard is the main component of a PC that connects all other parts together. Motherboards are categorized by size. ATX, the largest type, measuring 305 by 330 millimeters, designed for full tower cases. ATX measures 305 by 244 millimeters, commonly used in mid-tower cases. Micro ATX, up to 244 by 244 millimeters, used in smaller cases. Mini ITX measures 170 by 170 millimeters, suitable for small form factor cases. At the center of the motherboard is a socket for connecting the processor. This is called the CPU socket. There are two main socket types: PGA and LGA. In PGA, pin grid array, the socket has holes and the CPU has pins. In LGA, land grid array, the socket has spring-loaded pins and the CPU has flat contact points. The socket is surrounded by the CPU's power delivery system, called VRM, voltage regulator module. The processor is installed directly into the socket. The chip contains billions of transistors, and they are covered by a metal heat spreader. The size of these transistors is defined by the manufacturing process, also called the process size. The processor is responsible for executing all the incoming code. This is how programs are able to run. The CPU also includes a small, fast storage area called cache, used for data that needs instant access. Transistors generate heat due to electrical resistance, which is why the processor needs to stay within a safe operating temperature. To maintain that temperature, a cooler is required. A CPU cooler consists of a heatsink, a fan, and a base that makes direct contact with the CPU's heat spreader. Between the processor and the cooler is thermal paste, which ensures a tight connection and effective heat transfer. The fan is connected to the motherboard using either a 4-pin or a 3-pin connector. 4-pin fans allow for variable speed control, while 3-pin fans operate at a fixed speed. Code that needs to be accessed quickly is stored in the system's RAM. RAM consists of volatile memory sticks with memory chips and gold-plated contacts. Their physical shape is called DIMM, and the memory type is DDR. Storage devices. To store files that are not currently in use, PCs use non-volatile storage devices such as hard disk drives and solid-state drives. A hard disk drive consists of spinning metal plates and a magnetic head that reads or writes data, all inside a metal casing. A solid-state drive is made up of memory chips soldered onto a circuit board. The speed at which data is read and written is managed by a controller chip. Let's explain storage with a gaming example. All game data is stored on either a hard disk drive or a solid-state drive. When you launch the game, that data is transferred from the storage device to RAM, and then from RAM to the processor. The graphics card. The graphics card is like a computer within a computer. It has its own graphics processor, video memory, and a cooling system. The central processor builds the entire game world, but the graphics card determines how it looks based on your position in that world. Its job is to calculate the color of every pixel that appears on your monitor. Graphics cards are divided into two types: integrated, built into the CPU; dedicated, discrete, separate cards installed into the motherboard. Discrete graphics cards vary in size and in the type of cooling they use. Passive cooling uses only a heatsink. Active cooling uses both a heatsink and fans. The processor, RAM, and graphics card always work together. To transfer data between them, a special chip is required. This is called the North Bridge. Other components are handled by the South Bridge. Together, the North Bridge and South Bridge form the chipset of the motherboard.